Hello everybody. Today we are going to continue our chapter about exponential function, the third part. Let's start with limits. The limit of ex as x tends to minus infinity is equal to e power minus infinity. Just substitute x by minus infinity. I may take e power minus infinity down. It will be 1 over e plus infinity. E power plus infinity is plus infinity, so it is 1 over plus infinity, it is 0 plus. Now limit of ex as x tends to plus infinity, it is equal to e power plus infinity, which is plus infinity. So now the exponential function tends to plus infinity when x goes to plus infinity, and the exponential function ex goes to 0 when x tends to minus infinity. Limit of ex over x as x tends to plus infinity, it is equal to e power plus infinity over plus infinity, which is undetermined form, so I may use Hospital's rule. By deriving up and down, it will be the limit of the derivative of ex is ex, and the derivative of x is 1, so it is the same as the limit of ex over 1. Substitute x plus infinity by its value, it will be e power plus infinity, which is plus infinity. In other terms, I may say that at plus infinity, ex is faster than x. This means that when x approaches plus infinity, ex goes to plus infinity, but x is still on the way. Still on the way, I may consider it as a constant. So ex goes to plus infinity, but x is still on the way. That's why the answer is plus infinity. The same thing happens here. Limit of ex over x power n is equal to plus infinity. When x goes to plus infinity, ex goes to plus infinity, and x power n is still on the way. So that's why the answer is plus infinity for the same reason. What is the reason? Ex is faster than x when x tends to plus infinity, where n is an integer. Let's move now to the same function, ex over x, but in this time x goes to minus infinity. If I substitute minus infinity up and down, it will be e power minus infinity. E power minus infinity is 0. We found it here. And here, substitute x by minus infinity. In this case, I cannot apply Hospital's rule, but I may consider the answer as 0 for the following reason. X is faster than ex at minus infinity. X is faster than ex at minus infinity. So when x tends to minus infinity, x is faster. So x goes to minus infinity, but ex is still on the way. So it will be constant over infinity, which is 0. So this is the reason. I need my students to memorize this well. When x tends to minus infinity, x is faster than ex. So that's why it will be constant over infinity, which is 0. The limit of ex as x tends to minus infinity, it will be the limit of x over e power minus x. This is the proof why the answer is 0. I may take ex down. Why I took ex down? Because it will be e power minus x. If it is e power minus x and x tends to minus infinity, the denominator will be plus infinity. And this is minus infinity in the numerator. It will be infinity over infinity. By using Hospital's rule and derive up and down, it will be the answer, it will be 1 over infinity. The answer is 0. Let's take some examples now. Limit of x power n ex as x tends to minus infinity now. For the same reason, in this part, for the same reason, the answer is 0. I may say that the limit of minus infinity of x power n ex is the same as the limit of ex as x tends to minus infinity. I may take ex down, it will be x power n over ex. By using Hospital's rule many times, I can get the answer of 0, where n is an integer. Let's take some examples of limits and find the limit of the following functions. Limit of ex minus 1 over x as x tends to 0, it is equal. Substitute 0 up and down. This will be 1 minus 1, 0 over 0. Hospital's rule, it gives derivative up is ex, derivative down is 1. Now substitute 0, it will be e power 0, which is 1. Limit of ex over x as x tends to plus infinity. it is equal to plus infinity over plus infinity. By using Hospital's rule, derived up is ex, derived down is 1. Then the answer will be e power plus infinity, which is a plus infinity. It is too simple. Now I'm going to take examples about derivatives and domain of definition. We have 3 functions. In each function, I want to find the derivative and the domain. Let's remember what's the derivative of e power u. It is u prime e power u. What's u in our example here? It is radical x. So f prime x is equal to u prime e power u. U prime is 1 over radical x. This is the derivative of radical x. U prime e power u, finished from the derivative. Now the domain of this function is the same as the domain of u. The domain of u is what? X positive. So the domain of f is from 0 to plus infinity, finished from the domain of f. Fx equals e power 1 over x. F prime is u prime times e power u. U prime is what? Is the derivative of 1 over x, which is minus 1 over x squared times e power u. And the domain of this function is what? Is the same as the domain of u. Domain of u, x not 0. Not 0, so 0 is excluded. So it's from minus infinity to 0 and then from 0 to plus infinity. Finally, with the function fx equals ex minus 1 over ex plus 1. F prime is what? It is in the form of u over v. So u prime v minus uv prime over v squared. So it is the derivative of this ex times v, ex plus 1, minus u ex minus 1 times v prime, which is ex over v squared. Simplify this quantity, you will get 2 over ex. This is the derivative. And the domain, it is a fraction. Denominator should not be equal to 0. The denominator is ex plus 1. But the denominator ex plus 1 is always positive, so it's never 0. Why it's a positive? 1 is positive and the x is always positive. So it's never 0. Then the domain is all real numbers. Thank you for your listening. See you in part 4.